Now we discuss some basic terms which are related with singular solutions. The first term is the discriminant. You must have heard about this term. So we consider quadratic equation. Ax square plus bx plus c equal to 0. Now roots of this equation are given by the equation x equal to minus b plus minus square root b square minus 4ac divided by 2a. Now what is condition for repeated roots or equal roots? The condition is b square minus 4ac equal to 0. Okay, so if this condition is satisfied, then there is only one root, namely minus b divided by 2a. So this relation is called as discriminant relation, and the term b square minus 4ac is called as discriminant. B square minus 4ac equal to 0. This relation is called discriminant relation. And the quantity b square minus 4ac is called the discriminant of equation 1. Now if equation is quadratic, it is simple to find such relation, but in general we cannot have such formula, so we use geometry. Okay, so if we have a parametric curve and we change parameter values, then the number of roots may change. Okay, for example, for this parametric curve, for this value of parameter we have 4 solutions. For another value of parameter we have 3 solutions, and for one value we get one solution. Okay, now we can observe that at this point the tangent is parallel to x-axis, horizontal axis we can say. That means derivative is 0. Okay, so this geometry suggests solving given differential equation along with its derivative equal to 0. Okay, so the procedure is to find discriminant, solve or rather we can say eliminate x between 1 and its derivative with respect to x. So another equation is d by dx of ax square plus bx plus c v equate to 0. Okay, so what we get? We get 2 times ax plus b equal to 0. Okay, we have to eliminate x between given equation and this one. So 2ax plus b equal to 0 means x equal to minus b by 2a. Okay, so we substitute in equation 1. Substituting in 1, we get a into x square. So x square is b square by 4a square plus bx. So b into minus b by 2a plus c equal to 0. We simplify this. Okay, so this is b square upon 4a minus b square upon 2a plus c equal to 0. So we multiply this equation by 4a and we get b square into, this is 1 minus 2 plus 4ac equal to 0, that is minus b square plus 4ac equal to 0. We can multiply this by minus 1, so that b square minus 4ac equal to 0. Okay, so we get discriminant relation. Okay, so for given equation in some variable, we can find discriminant relation by eliminating that variable from given equation and equating the derivative of that equation to 0. Okay, so let us see p discriminant. Okay, this was introduction. Now we will discuss two types of discriminants which are related to given differential equation. P discriminant. So consider nonlinear first order differential equation f of x, y, p equal to 0. Okay, some relation between independent variable x, dependent variable y, and p is dy by dx. Okay, the p discriminant is the relation between x and y whose vanishing implies that the differential equation 1 has equal roots for P. Okay, so how we obtain such a relation? Such a relation that is the P discriminant is obtained by eliminating P between equation 1 and del P by del F by del P equal to 0. The P discriminant of 1 is obtained by eliminating P between 1 and partial derivative of f with respect to P equal to 0. Okay, this second relation. Now next thing is C discriminant. Okay, so we consider the differential equation 1, find its solution. It will contain arbitrary constant C and we find C discriminant for that solution. Okay, so let phi of xyc equal to 0, call it as 3. So this be the solution of differential equation 1. The C discriminant of 3 is obtained by eliminating C between 3 and partial derivative of 5 with respect to C equal to 0. So this will be useful in finding envelope and singular solutions. Now we see the envelope. So consider the solution phi of x, y, c equal to 0 of differential equation f of x, y, p equal to 0. So if we change c, we get different solution. Okay, so we can say that phi of x, y, c equal to 0 is a family of curves, and all these are solutions of differential equation 2. For each possible value of c, one gives a curve. Now if we consider two values for C which are very close to each other, then we get two curves. These are called as consecutive curves. Curves corresponding to two consecutive values of C are called consecutive curves and their intersection is called an ultimate point of intersection. So we can have figure. So the example discussed in last lecture. So we have general solution as family of circles centered on x-axis and fixed radius a. Okay, so if we consider center as C0 and for consecutive curve, the center is slight change in C. Okay, say C plus delta 0. Okay, so this is phi of xy C equal to 0 and this is phi of xy C plus delta. Okay, C plus delta is slight change in C equal to 0. We get these two curves. So these are consecutive curves and these points in the limiting case. Okay, of course these will be very close to each other and by naked eyes we cannot distinguish them. Okay, so these points will be very close to y equal to a and y equal to minus a. Okay, so limiting positions are y equal to a and y equal to minus a. So these are ultimate points of intersection. Okay, and these are nothing but y equal to a and y equal to minus a. So these are ultimate points of intersections. Now what is envelope? Envelope is limiting position of these ultimate points. The limiting position of these points of intersection includes the envelope of the system of curves of family of curves or system of curves. Family is phi of xy c equal to 0. Now, what is envelope? Envelope means the curve which should touch to each member of family. Okay, a curve which at each of its point is tangent to an element of a one parameter family of curves. What is meant by one parameter family? The family which contains one parameter. For example, here it is phi of x, y, c equal to 0. C is parameter. Is called an envelope of that family. Now we discuss how to obtain these envelopes. There are two ways. One way is to find P discriminant and other ways to find C discriminant. Okay, so the P discriminant and C discriminant provide envelope. So it is by using the techniques in differential calculus. It is shown in the works of differential calculus that the envelope is part of C discriminant solutions. Part of C discriminant. That is, eliminate C between the solution phi of x, y, c equal to 0 and del phi by del c equal to 0. Now another way is P discriminant. So envelope can also be obtained by using P discriminant solution. We are not going to see the proofs of these things. Now we discuss singular solution. In the last lecture, we have seen a solution which was not part of general solution. That means which cannot be obtained by assigning particular value to arbitrary constant C in general solution. Singular solution. a singular solution of differential equation f of xyp equal to 0 is any solution that is so first thing is not a special case of the general solution, and second thing is at each of its point tangent to some element. So this solution at each of its points is tangent to some element of general solution. Okay, that is the family phi of xyc equal to 0. Therefore, we can see that the envelope is satisfying these conditions. Okay, so equation of envelope is singular solution. Equation of envelope is also a singular solution. Okay, if we consider singular solution, then if we consider envelope, then at each point of envelope, it is tangent to some solution curve. Okay, so that means each point of envelope is satisfying given differential equation. Okay, so it is also a solution, and of course it cannot be obtained by assigning only one value of arbitrary constant c. We see example.